In past episodes, we've talked about convergent and divergent plate boundaries. Seafloor spreading creates new oceanic lithosphere at mid-ocean ridges that occur at true divergent plate boundaries. And this creation is balanced by destruction of old oceanic lithosphere at convergent plate boundaries. These two types of plate boundaries are marked with ridges and trenches and explain the birth and death of the plates. However, if we project these plate boundaries on the map, we can see there are gaps in the outline of the plates. There must be another kind of plate boundary. The third type of plate boundary is called a transform plate boundary and is marked by transform faults. Transform plate boundaries don't create or destroy lithosphere. Instead, transform faults allow oceanic plates to slide past each other. Transform faults can connect with either divergent or convergent plate boundaries. There are many transform plate boundaries all around the world, both on land and in the oceans, just as there are for other types of plate boundaries. Transform plate boundaries can therefore be subdivided into two groups, oceanic and continental transform plate boundaries. Let's talk about continental transform boundaries first. The San Andreas Fault in California is the only transform plate boundary in the United States and is one of the most famous in the world. This transform fault can be traced for 750 miles or 1,200 kilometers from near the border with Mexico to north of San Francisco, where it continues on the sea floor. The San Andreas Fault connects two divergent plate boundaries, the East Pacific Rise in the south with the Juan de Fuca Ridge in the north. The San Andreas Fault separates two of the Earth's biggest plates, the Pacific Plate in the west and the North American Plate in the east. The fault is often easy to see because it makes long, straight depressions and uplifts. Depressions along the fault are often filled with water to form long, narrow lakes or bays. You might have heard an idea that California west of the fault might fall off into the ocean. Because of how transform faults work, this would never happen. However, at the slow rate of about 5 centimeters each year, the western side is moving north as the two plates slide past each other. Over millions of years, rocks that formed in Southern California have moved to Northern California. Because of their side-by-side style of motion, transform plate boundaries are different than the other plate boundaries in that they don't produce volcanoes. However, like the other types of plate boundaries, they do produce earthquakes. Earthquakes happen when there is motion along a fault. Small amounts of motion cause small earthquakes, and large amounts of motion cause big earthquakes. About 10,000 earthquakes happen along the San Andreas Fault every year, but most are so small they're not even felt by people nearby. Large earthquakes happen less often, but when they do, they can cause a lot of problems. Because cities like San Francisco and Los Angeles lie near the San Andreas Fault, big earthquakes along it can cause a lot of damage. Such a big earthquake happened in 1906 near San Francisco, killing 3,000 people and leaving half of the city's 400,000 people homeless. A much more deadly earthquake struck the Caribbean island of Haiti in 2010. Haiti lies near a transform fault boundary between the North American Plate to the north and the Caribbean Plate to the south. Buildings were not designed to survive such an earthquake, and many collapsed. Over 100,000 people died as a result of this terrible earthquake. People that live near transform faults need to be prepared for big earthquakes. Oceanic transform faults are also important. The most spectacular examples of oceanic transform faults are found in the Mid-Atlantic Ridge, between Africa and South America. These connect the spreading ridge and divergent plate boundary in the northern Atlantic Ocean with the spreading ridge and divergent plate boundary in the South Atlantic. The northern and southern parts of the Atlantic Ocean open separately, and these oceanic transform faults connect them. The offset of the divergent plate boundaries, farther west in the north, farther east in the south, was accompanied by these oceanic transform faults. The difference in the position of the spreading ridges in the Atlantic Ocean is also what causes the shoreline in the southern part of West Africa to trend east-west, parallel to the oceanic transform faults of the region. There are many other examples of transform plate boundaries around the world. Take a look at a map and see if you can find the one in New Zealand and between Israel and Jordan. They're not hard to find, just follow the plate boundaries. Now we have covered 3 types of plate boundaries: convergent, divergent, and transform. In the next episode, we will talk about how scientists came up with the theory of plate tectonics. See you next time.